Hey, all right, we're here. Last one. You're either glutton for punishment, you really like naming, or you just had nothing better to do, right? So anyway, here's our last one of the nomenclature videos here, which is all about addressing names and formulas for acids. So I'll do a quick definition here, and then we'll kind of buzz through this. This should hopefully be a little bit of a shorter video, I hope. So acids are fun, right? We like, acids have been studied for years because they're just so reactive. I mean, they eat metal, they fizz, they do all kinds of cool stuff. Hydrogen comes out. They're sort of entertaining. And so acids have been like on the top of chemists' minds for quite a long time. So how do we know what an acid is? Well, from the even the last video, you might recognize that it has something to do with like those acidic salts, right? I mentioned that in there. The key thing, how do you know if it's acids? This one. Almost always, if the first element that's present is hydrogen, it's probably an acid. And so we can have hydrogen does a lot of different things, and it's a really flexible element. It's kind of cool, some of its behavior and stuff that it does. But looking for hydrogen as the first element present, except for organic compounds, is a really good hint that this is going to be an acid. And something about having hydrogens present, the hydrogens then escape, and something about having these sort of naked hydrogens running around is particularly reactive and particularly caustic, toxic, corrosive, all those good things that hydrogen ions do. So that's really what you're looking for. If you see the first element is hydrogen, maybe a thought that that's probably an acid that's on there. So our first category is going to be binary acids in terms of what they are. So this isn't too common in terms of what they would be, but there's a really common example of one that you all have heard of. This isn't all that common in terms of all the acids that are out there, but this one is incredibly common. I know you know what this acid is. This one is hydrochloric acid. Okay, so that's two words. There's the word break. Hydrochloric is one word, and acid is the second word. So let's take a look at how this thing is named and kind of take it apart, and maybe you can start to kind of pick out what some of the rules are. So first of all, we see that there's that language root in there, right? It's got chlorine in it, so of course it's got the CHLOR in there. The ending is different though, right? Notice what we've got for our ending here. This is its original name, by the way. If we didn't want to name this as an acid, it has another name, hydrogen chloride, L-O-R-I-D-E. I forgot the H, C-H-L-O-R-I-D, right? That's its non-acid name. It's a different systematic name. But if we're trying to really emphasize its acidic characteristic, and this is specifically for like when it's dissolved in water, specifically a solution is where this really comes into play. We change the name a little bit. So again, it's maybe its gas name would be hydrogen chloride. But take a look at it. We've got the CHLOR, tells me the root, that's chlorine that's present. And then we have two different things that are about this name that are changed. First of all, the ending has changed, right? It's no longer IDE, it's IC. The second thing that we have is we have this prefix hydro on the front. So binary acids always start with the prefix hydro, always, and they always end with the suffix IC. Whenever you see this, hydro and ic, and then the word acid, the word acid kind of gives it away. But that keys you into the fact that that is indeed a binary acid. Again, that hydro on the front is that number one hallmark that this is a binary acid. Hydro means binary in this particular case. And with all of the acids, we're gonna change the endings a bit as well. So let me give you another example of one so you can kind of see what you would talk about. Some other examples of binary acids that are out there. We could have HF. We can have the friendly acid. That's my favorite one. HI is another one on there. Are the two most common ones. I'm just going to leave it right there and name these guys. So this one, if we're going to name this, it would have been hydrogen fluoride, but now as an acid, we would call it hydrofluoric. HYDROFLUORIC acid. Hydrofluoric acid. Hydrofluoric acid is particularly nasty. It's actually one of the only things that will eat glass. Almost everything else can be stored in glass, but hydrofluoric acid is so unpleasant between having that super reactive hydrogen and then super reactive fluorine in there, it will destroy glass. So hydrofluoric acid has to be kept in plastic, but that's what's used for glass etching. Note for the day. And the friendly acid, hi. So this is spelled really weirdly. So again, hydro, and then it's iodine in here and ic. So hydro, IODIC. There you go. Hydroiodic acid. Really weird one. I know that's really bizarre. Hydroiodic. Hydroiodic acid. Those are binary acids, and those are really the only ones that you'll end up seeing. But hydrochloric acid is incredibly, incredibly common, and I know you know that one. So most of our acids are acids that are formed with polyatomic ions. And so these would be some other acids that you may have heard of, like sulfuric acid or nitric acid or phosphoric acid. These are polyatomic acids. And there's a nice systematic name translation that gets done with these. So let me point out the couple of common ones that you guys know. This is nitric acid, HNO3. And this is sulfuric acid, H2SO4. So let's talk about how these are named. Okay, nitric acid. This one makes sense because nitrate, it's a 1 minus, hydrogen's a 1 plus. So you can see our formula, 1 plus 1 minus, they balance each other out. This would have been hydrogen nitrate. That would have been its original name. So when we write it as an acid name, we get rid of the word hydrogen that no longer appears. We're going to use the word acid instead, ACID. The nitrate, we're going to change slightly. We change this ending to ic, Nitric, nitric acid. So we have one translation, 8 becomes ic. So if you ever have a polyatomic that ends in 8, the name of the acid ends in ic instead. So this is going to be kind of similar. So this one right here would be hydrogen sulfate, hydrogen sulfate. And again, if we want to write this in its acid name, again, we're not going to use the word hydrogen. We're going to use the word acid instead. And then we're going to change the sulfate to the ending ic instead. And this becomes, it changes slightly. Instead of calling it sulfic, I'm not going to mark it wrong if you do, sulfuric. I guess they thought it sounded better. If you wrote it as sulfic, S-U-L-F-I-C, I get that you know what we're talking about, but sulfuric acid. Now keep in mind, this is different than hydrosulfuric acid. Hydrosulfuric acid, H-Y-D-R-O-L-F-U-R-I-C. As soon as we put hydro on the front, that means it's binary. So that means it's H and S. No oxygen present. This is what makes it super confusing. Sulfuric acid is a polyatomic. Hydrosulfuric is binary. Again, the word hydro means it's binary. So if you take a look at our ions here, sulfur as an ion is a 2 minus, hydrogen is a 1 plus. So H2S would be hydrosulfuric acid as opposed to sulfuric acid. Again, sulfuric acid is a polyatomic. Hydrosulfuric is hydrogen sulfide gas dissolved in water, H2S, versus H2SO4. It's a little bit unusual in terms of what they are. So polyatomic acids. Okay, let me do another one. What if it ends in an ic instead? So hold on. Let me see if I can delete some of this here. Clear off my space. Okay, so hold on. There we go. There we go. Get rid of these guys. Get rid of these guys. Okay. So our friend, chlorate, is a great example of one to use for this. So if we have HClO3, this would have been hydrogen chlorate, ATE, right? So if we write this as an acid name, we change the ATE ending to ic. It's not hydrogen chlorate. This is chloric acid. Why isn't it hydrochloric acid? Okay, and remember, when we see the word hydrochloric, H-Y-D-R-O, acid, there we go, hold on. Hydro means it's binary. There's no oxygen present. Hydrochloric acid is HCl, not HClO3. So again, hydro means it's binary. We're still changing the ending to ic. That's the same in both of them. So HCl3 was hydrogen chlorate, hydrogen chloride. What about hydrogen chlorite? HClO2. So there's a different translation for these. We got to use a different ending, just like ate and ite. This was the ITE form. Well, there's a different ending as well. This is CHLOROUS, Chlorous acid. Sounds really, really weird, doesn't it? So if it's ITE, it goes to OUS. And again, I know that is strange. You are not used to these things. Hydrochloric is the one that's going to roll off your tongue. Hydrochloric is the binary acid. Chloric acid is hydrogen chlorate. Chlorous is hydrogen chlorite. So I'm going to give you one more example here, see if I can kind of figure out if I can trick you, not really trick you, but give you an example of practicing this. The ate and the ite is going to ick and us. It's definitely a very strange sort of experience. So, and again, the OUS acids are pretty rare, just like the ITE versions are pretty rare. So here is the difference. I'm going to have you guys write sulfuric acid. So go that direction. If you're talking about sulfuric acid, as soon as you see acid, okay, I'm going to start with hydrogen. Sulfuric, there's no hydro out here, right? So this means it's got to be the ATE form. So sulfuric acid has got to be hydrogen sulfate. Now we got to balance our charges yet. Sulfate's a 2 minus, hydrogen's a 1 plus, H2SO4. All right, so what's this one going to be? H2SO3. We're going to go the other direction, I guess. So the top one is hydrogen sulfate. This one is hydrogen sulfite, right? That's the ITE form because it's got one less oxygen. So when we write this one, it's not sulfuric acid. We have to use the other ending. It's the OUS ending. And this sounds really weird. F-U-R-O-U-S, sulfurous acid. And we can do the same thing with phosphorus acid. S-P-H-O-R-O-U-S, phosphorus acid. So if you want to think about this one, again, we'll go this direction. Phosphorus acid, A-C-I-D. Acid means there's hydrogen there. Give myself some room to roam here. And there we go. We know that it's got a hydrogen in there. Phosphorus. When I see this OUS ending, that tells me it's ITE, so it's got to be phosphite. Phosphite, well, PO4 is phosphate, so PO3 is phosphite. And then I don't change my charges. I still got to balance my charges. Phosphate is a 3 minus. Phosphite is also a 3 minus. So this would be H3PO3, phosphorus acid. So there you go. Definitely a little bit awkward in terms of dealing with these. Again, the couple of big things to deal with is the ate to ick, ite to us. The other one that goes along with that, again, is over on this side. Hydro and ick means it's binary. So that's what you would see in terms of IDE. So our endings, again, one last time, I'm going to kind of clear. Oops, that's not what I meant to do. Sorry. Let me do this one. Our endings that we want to kind of think about in terms of kind of summarizing this up. If you see this one, hydro and ick, that means that the compound itself was IDE, binary. If you just see ick by itself and the word acid, every one of these over here would have plus acid. Every single one of those. Hydro, ick, acid, or just ick and acid. This means it's an ATE. This by itself without the hydro means it's polyatomic. If we see this one, OUS, that means it was the ITE form. And again, all those are the same. You can, by the way, you can have these two prefixes, per and ick, and hypo. HYPO, not hydro. Hypo and us can come together as well. So those two prefixes don't change. So you could have a per and an ate and an hypo and an ite, just like you can have the same things with your acid names. So there you go. That's a quick overview of dealing with some of the acid names. It's definitely a little bit awkward. Again, I try to think of it as a translation. It always has hydrogen on the front, and you're just changing that ending from IDE, ATE, or ITE to ick and us. There you go. Good luck with that one, and I will see you in class.